Hi there, welcome. My name is Kathy. I'm with the Friends of the Planetarium. And we were hoping to live stream this, but we're going to give you a recording of it after the fact because we're having a little trouble with the connection. But tonight we have astronomers Teresa Wilson and our very own Jennifer Bartlett. They're going to talk to us about the moon and calendars and supermoons and all sorts of fun stuff. So I'm going to turn it over to them and let them do the talking.
Good evening. The full moon is rising today. It is supposedly a supermoon. However, the forecast was not really cooperative, so I'm not sure whether we will get a nice show this evening. I hope you had a chance to see it last month, because it will be another full year until we have another supermoon opportunity. This moon also coincides with the feasts of Passover and Easter.
Jennifer, when you say that you hoped that we could see it last month, does that mean there was a supermoon last month too, or just this month?
Last month was also a supermoon by most definitions, although the definition is really unclear.
So there's more than one definition of a supermoon.
Yes, it's just getting into the dictionaries. And when I looked up today, it's kind of this vague reference to a moon that is somewhat closer than average, and a full moon that occurs when the moon is somewhat closer than average to the Earth, and so it will appear bigger and brighter, hence getting a lot of hype. But that's not really a technical definition where we could come down and say, yes, it's definitely in or out supermoon. The term appears to date back to the 1970s and the writings of an astrologer, Noel, who thought that if you had either a new moon or a full moon that occurred when the moon is within 90% of perigee, then bad things, earthquakes, tsunamis, some kind of disaster would occur within 3 days of this event. But that's pretty wide open. You've got a whole world, you've got a 3-day window, a lot of slop in the definition of what's close enough. You can probably find a disaster that would meet his criteria. Astrology.
Well, I think the current global crisis started before the supermoon, so
yeah, I don't think we can blame that.
Can we blame that on the supermoon?
On the supermoon. And while he considered it both a new moon and a full moon, people really aren't interested in bigger than average new moons that you can't see.
I was going to ask about that.
So in colloquial, it seems to talk about just big full moons.
Okay.
And we get this because when two cycles seem to align, we have multiple definitions of the month. So we have a sidereal month, and that is the moon orbiting the Earth. It's a pure 365 degree, it's 360 degree turn, a circle, kind of what you think of an orbit being. It takes a little more than 27 days. But then there's also a synodic moon and that month, and that's what we really think of as the cycle of the phases, because that's a much more dramatic change. And you need to align the sun, the earth, and the moon for full moon, and then wait for it to come back to that. It takes a little bit more than 360 degrees because everything's moving. The earth's moving around the sun while the moon's moving around the earth. And so this takes about 29 and a half days. And this is the underlying thought to our calendar months.
Do astronomers care about the supermoon at all?
Not usually. I mean, we're interested in alignments, of course. I think the technical term is actually perigee, syzygy, but
that what you had on the last slide was a real word?
yes. But But in your career, has anyone ever come up to you and asked you about a syzygy?
Thank goodness, no. I would probably accuse them of making up words.
No, I wouldn't do that to you. So a syzygy is an alignment, and perigee is when we are closer. It's the closest point in an orbit to the Earth.
Sure.
From peri, close in Greek, and Gaia, the Greek goddess for the Earth. And the Johannes Kepler wrote 3 laws of planetary motion, which kind of explain how the planets go around the sun. Isaac Newton realized that these were more general rules, and they apply to the orbit of the moon around the Earth as well, or any satellite around its host body. We will stick to only one of those rules tonight to get us kind of this idea of perigee and timing.
Okay.
So Kepler's first law says that an orbit is not a circle, it's an ellipse. So it's a little egg-like, and that means that sometimes the orbiting body is closer to its host than usual. That's our perigee. And sometimes it's a little bit further from its host body, and that is apogee. The trick being that A is away. I wish I had known that when I was still teaching, because it now sticks in my head, but it didn't when I was trying to explain the terms before. So hopefully that helps somebody else. Don't know who the old astronomer was, though, who came up with it. So when we're talking about closer than average, the average distance of the Earth and the Moon is about 238,000 miles. At perigee, it can be as close as 221,000 miles. At apogee, it can be as distant as 253,000 miles, so a difference of 50,000 miles. But the orbit of, or the radius of the Earth is 4,000, to give you some kind of sense of that. So we're looking at the Moon at perigee being about 7% closer, and the Moon at apogee being about 6% more distance. And this means that a supermoon could be appear 14% bigger to us and maybe 30% brighter than a micromoon. A micromoon is occasionally used as a term to refer to moons that are full moons that are closer to apogee and therefore a little bit smaller than usual. But for some reason, you only see that in comparison. Supermoon versus micromoon. Micromoons on their own don't really get a lot of press.
I was going to say, are there natural disasters associated with micromoons?
No, but it can ruin your eclipse. That's the difference between a total solar eclipse and a hybrid eclipse with the ring of fire. Because the moon's no longer, if it's at apogee, it's no longer big enough, appears big enough in the sky to completely cover the sun. So over the course of the month, the moon waxes and wanes. We are now at full moon on April 7th. So the moon is opposite the sun. As it is rising now, the sun is setting. So it will be big and bright and up all night. Then in the succeeding nights, it's going to rise a little bit later in the evening, and it's going to be a little bit less full. We call this waning gibbous. Waning because it's shrinking down, and gibbous is from Latin for hunchback. Did you ever have to use that term in Latin class?
I'm sure we did at some point. I don't remember Cicero talking about too many hunchbacks.
Again, one of those like, why do we know this? Well, they keep telling us that studying Latin is good for our English, but So it's referring to this kind of crouch back shape. So you've got at least half of the moon is illuminated, and then you've got a hump sticking out from that illuminated portion. And about the 14th, next Tuesday, it will be down, so you'll just have half of the face illuminated. The face that's looking at us, the side facing us, is illuminated, and that will be last quarter. And then it's going to keep shrinking, and now it will be a waning crescent, and we'll have this little sliver of a moon that will disappear on the 22nd, and that will be new moon. At that point, the moon's going to be on the side of the Earth, the same side of the Earth as the sun. And so the illuminated side will be facing away from us, and we really won't see anything. But give it another night or so, and you will start getting a waxing crescent. So a little sliver that waxes or gets fuller each night until the end of the month, when we'll have about half of it, or the first quarter. And then it will cycle back around, and we'll have another full moon on May 7th.
So is there a trick for remembering waning versus waxing besides some kind of wax on, wax off?
Wax on, wane off.
Wax on, wane off. All right.
For those people who remember Karate Kid.
Yeah, this audience might be a little too young. I don't know.
So we get these different phases as the moon is moving around the Earth and the Earth is moving around the sun. At all times, half of the moon is illuminated. It just may not be the half that we see. And so we have these names for the different effects that we see. And we consider 4 major phases. So that would be new moon, when we don't see anything; first quarter, when half of the moon is illuminated by the sun, but only a quarter of that we can see. Or we see a quarter phase illuminated. And then full moon, we get the full view of the illuminated portion, and then it begins back to a quarter. The third quarter, or last quarter, is illuminated from the left, which is how I remember it. So if you're looking up, at least in the northern hemisphere, the side will be illuminated if you are looking at a waning moon versus a waxing moon, which is illuminated on the right. So we talk about another syzygy would be opposition at full moon. That would be the fancy name for the moon being on the opposite side of the Earth from the sun. That gives us this full face that we see. The bright, it's big, it's bright, it's doing the opposite of what the sun is doing. So with moonrise, we have sunset. So big and bright and up all night. In military terms, this would be a good time to defend. And then in 2 weeks, it will have shrunk down to new moon. At that point, it's going to be on the same side of the Earth as the sun, so it will do what the sun does. It will rise at sunrise and set at sunset, and that makes it very difficult to see. It's basically lost in the glare of the sun. But give it a few hours and it will start to move a little bit further away from the sun, and as it does that, we begin to distinguish a crescent moon. In the Jewish calendar, the month traditionally began with the first sighting of the waxing crescent. They now have a computed calendar, but the months roughly approximate the lunar cycle. In the Islamic calendar, they still look for an actual sighting of the crescent moon. That's fairly difficult. The moon on the last slide was 37 hours old, but according to reliable reports, under the best of conditions, you can see it about 15 and a half hours after it's new. But as you can see from how small a 37-hour moon, that's more than a day passed. It's still a little difficult to make out, but it's substantial. So now we have months and we have years and we try and fit them all together. The calendar that we use now kind of goes back to the Roman system. And according to legend, Romulus, back of Romulus and Remus and the wolf.
Founders of Rome?
Yes, founders of Rome. One of the things they did, in addition to giving us the eternal city, they worked out a calendar of 304 days, which doesn't quite get to the 365 that we expect in a year. So that didn't work really well. In the next generation, you have Numa Pompilius, who added a couple extra months. So you have Martis, Aprilis, Maius, Junus, and then he starts losing interest in naming months, I guess, because we got Junus, 5th month, 6th month, 7th month, etc. But this is 355 days. So it's a little better, but it's still not right on. And what they would do is they would have the priests insert an extra month, Mercedanus, when they thought they needed one to bring the calendar in alignment with the seasons. So you can add a leap month or a leap day here and there.
And they were basing their months on the lunar cycle?
They're trying to keep both a rough estimate of lunar months and also seasonal.
Okay.
So you want the vernal equinox to be in March, with the beginning of the year.
Okay.
And but if you think about Roman politics, the idea of letting someone add some time to the year when they thought they needed it,
yeah,
that's just ripe with corruption. Oh, we don't need an election this month. I'll wait for some better omens, or we need another month. We'll just put it off.
Right.
So Julius Caesar, we think about him as being the first emperor or the imperator, great general. But before he went off to win fame and fortune, he was also Pontifex Maximus, and that means he was the chief high priest and responsible for things like the calendar. But he didn't pay a whole lot of attention to it when he was off conquering Gaul. But then he was in Alexandria trying to conquer, or at least bring under Roman control, Egypt. That's when he dallied with Cleopatra. Apparently, she also invited her astronomers to at least some of those parties. And they suggested the leap system of 3 years of 365 days, and then every 4th year you have an extra day. So when Julius Caesar returned to Rome and started trying to reorganize civil life, that is the calendar that he came up with. Although we like to put our extra day in February at the end and give us 29 days in February. He thought that you should just have 2 24ths of February.
Okay.
So you'd have 6 days, and then you'd have another 6 days before the end of February, bisextus. We think that odd. Apparently it was okay with them. And he said that the vernal equinox should fall on March 25th. And then to get the calendar aligned with the seasons, he extended the year to 445 days, once otherwise known as the Year of Confusion. It was 46 BC.
Is that what caused him to the Ides of March to not go so well for him?
I'm not sure that they could directly tie it to his calendar manipulations, but they certainly
have to drive me mad. So
that would have justified homicide in your book.
You know.
Well, they then rewarded him by naming one of those number months after him. That's where we get July. And then his successor, Octavian Augustus Caesar, got August on his death. And then apparently they stopped naming months after emperors, or
Brutus, who was an honorable man.
they were the emperors who tried to name additional months after themselves. It didn't last very long. Wasn't that like one of Commodius's things? I don't remember. So the vernal equinox is one of those 2 points during the year when we have equal light and dark. So roughly at 12 hours of light and 12 hours of darkness. We experienced that on March 19th of this year, and then on September 22nd we'll have the autumnal or fall equinox. If we were in the North Pole, we would see the sun rise on the vernal equinox, and it would stay up all summer and then set for the long winter night on the autumnal equinox. But here in the mid-latitudes, it's not quite that extreme, although we start to realize that our days are definitely longer than our nights, and it will reach that maximum in the summertime. So Julius Caesar had established his calendar, and then when Emperor Constantine started officially promoting Christianity in the Roman Empire, he called the Great Council of Nicaea in 325 AD, and that gives Christians the Nicene Creed, but it also set the rules for calculating Easter. Constantine wanted the Christians throughout his empire to celebrate Easter on the same day. And what they knew from the gospel writers is that Jesus supposedly rose from the dead very close to the Jewish festival of Passover. And Passover occurs on the 15th of the Jewish month of Nisan. In a sense, months were roughly tied to the lunar cycle, 15 days, 2 weeks after new moon. That's basically a full moon. Okay. And this year, the 15th of Nisan begins at sunset tomorrow. So this is the Passover moon.
Oh, tonight is?
Yes.
Oh,
well, tonight.
Or tomorrow?
Tomorrow is the beginning of tomorrow at sundown is the beginning of Passover.
Okay.
And it's this full moon. The distinction between tonight and tomorrow night being full is almost unnoticeable to the unaided eye.
Right.
And although full moon is technically at 10:35 tonight. But
so is this about the closest to the full moon that Easter ever gets, or?
You could have it right on. So you could have vernal equinox, full moon the next day, and then Easter the following if it lines up. So the rule,
when Easter happens really early.
Yeah. Yes. So the full moon fell on Saturday, then you'd have full moon and then Easter right on top of each other. But the rule that they worked out at the Council of Nicaea is that Easter should be the first Sunday after the first full moon after the vernal equinox.
Yes.
They couldn't go back and say, oh, well, we want the first Sunday after Passover, because while the Jewish calendar was in the transition in the 300s from an observed calendar to a calculated calendar, the Sanhedrin really wasn't interested in sharing that information with Constantine.
Right.
It was one of those closely held, we control the calendar, we know what's going on approach. And then because of the difficulties of calculating both when the vernal equinox will occur and the lunar cycle, in an age without supercomputers or even desktop computers or let's face it, electronic calculators.
Right.
The Romans took a number of shortcuts. So one of them is that they said, we're not really sure when the vernal equinox will be. We'll just assume that it's March 21st, or at least most of the Roman Empire did. A few of them said, well, wait, Julius Caesar said that the vernal equinox should be on the 25th.
Mm-hmm.
There'd already been drift, so that they were seeing the equinox at Nicaea on the 21st. So there was some controversy, again, even on when the vernal equinox should be. But over time, kind of smoothed out. The agreement was, we'll pretend that March 21st is always the vernal equinox. But if you continue to let your calendar drift, and the Julian calendar drifts about 11 minutes a year.
Okay, so that kind of adds up after a while.
A bunch of monks and astronomers started saying, you know, the vernal equinox isn't happening on March 21st. We might be celebrating Easter on the wrong day. And
oh no.
Really, this is terrible.
What will we do?
But it took a couple hundred years before the Pope took an interest in the problem. It's like, yeah, that's good. We probably should do something about it. Not highest on my list of things to do. But Pope Gregory, I think it's 13, in the 1570s said, yeah, this has gone on too long. We need to work out how to get Easter back at the right time of year. We want to observe it on the right day, and we want to follow the same rules that were set down in the Council of Nicaea. Okay. So this gives us what we call a Gregorian calendar, because he promoted it. Actually, he required it in Catholic countries. The Protestants were a little bit leery of it. But it's the leap year rules that we're familiar with. So yes, February's 28 days. And then we have that leap year like this year on the 29th. But then in century years, he says, we're going to skip leap years in century years unless the century year is divisible by 400. And this means that the year 2000 was a century leap year. So February had 29 days. But in 1900, there was not a leap year, even though it was a century year. And 2100, I'm not going to live that long, but it won't have a leap year. It won't be a leap year either. And then he wanted to get the vernal equinox back on March 21st, where the Council of Nicaea indicated it should be. So he just said, we're going to drop 10 days from the calendar. Julius Caesar, he got killed when he did the year of confusion and put extra days in. We're just going to take it out. So in October 1582, it went from October 4th to October 15th.
Awesome.
And after people got over the stress of losing 10 days of their lives and being like, I'm not sure where that went.
I have a hard enough time with daylight savings and just losing an hour. So I don't know what I would do if I lost 10 days suddenly.
Worse if your birthday was in there.
Kenny points out that if your birthday fell during those 10 days, you'd be really unhappy.
Oh, that would suck.
Fortunately, I'm a September girl, so it wouldn't have bothered me. It took a couple hundred years for the Protestant world to come around to using the same calendar as the Catholics, and that put us all kind of on the Gregorian calendar. We use it for civil purposes today. But the Orthodox community did not accept this reform. They're like, Council of Nicaea used the Julian calendar, we're using the Julian calendar. So there are now 13 days difference between the two systems. So while in the Gregorian calendar we're having April 7th, in the Julian calendar it's only March 25th.
That's not confusing at all. Okay. All those 11 minutes, they add up.
They do. You let the centuries pass and they keep adding up. So they calculate from March 21st, Julian calendar, which is 13 days behind the Gregorian calendar. And then they start their first full moon after the first Sunday after the first full moon after March 21st in the Julian calendar. And with a little bit of differences in the kind of the shortcuts that were taken in the ecclesiastical calendar, both the Western and Orthodox Christians do this. Orthodox Easter will be on the 19th of April. So as you and I, being Western Christians, celebrate Easter this Sunday, my Orthodox relatives, our friend Nick Stomaticus, will be celebrating Palm Sunday. And then they will have their Easter a week later.
Okay. How do those 10 days that we lost in 1582 affect the 2-week difference between the Julian calendar and the Gregorian calendar?
Well, the gap has continued to widen since 1582.
Right. So did we have, it was a 10-day difference in 1582 and now we're up to 15 days?
No, 13 days.
13 days. So we've gained 3 days since 1582?
Yes.
Okay.
But faithful Christians of both persuasions will share Easter in 2025 because the cycles will line up just so. Until then, be careful who you wish a happy Easter, because if they're still fasting for Lent, they might be grumpy.
Hadn't thought about that. Good to know.
But in 1923, there was a pan-Orthodox Congress that took up calendar reform at a certain level, and they said, we can come up with a better revision to the Julian calendar than the Gregorian calendar.
Okay.
So they suggested a different century rule. And so you got a leap year every 4 years, but then instead of century years divisible by 400, which is what it is in Gregorian, they say, well, a century year will be a leap year if you get a remainder of 200 or 600 when divided by 900. Yeah, I don't want to try pounding that into the heads of school children.
Nope, I'm not sure I want to even know how they came up with that math.
It's Milankovitch, the same guy who did the cycles for climate change. It's his math. And you don't actually have to worry about the details because it has the same century years, the same leap years as the Gregorian calendar until 2800.
So why are we worried about it then?
It's better. It's a better system. It's
Better
slightly
system.
more accurate.
We'll worry about 800 years from now. Perfect.
Neither me nor my great-grandchildren will have to take that one up. So the Gregorian calendar, the Julian calendar, and the revised Julian calendar, if you will, are lunisolar calendars. They have both a lunar aspect in that we have months embedded in them, and solar in that we keep up with the sun and the seasons. The Islamic calendar is purely a lunar calendar. So it takes into account the months and just ignores what happens with the years. There's no effort to sync the two of those up.
Okay.
And because of this, it works out to being about 11 days short of a solar cycle. And so the months of the Islamic calendar drift with respect to the seasons and cycle through the seasons. So later this month, the holy fast of Ramadan will begin, in which the devout abstain from food and drink during the hours of daylight.
Yeah.
Right now, for those of us in the Northern Hemisphere, it's in spring. So reasonably close hours of light and dark. But as it keeps drifting against the seasons, it will be a little bit earlier in April next year, April according to the Gregorian calendar, and then it will move into March. Eventually, Ramadan will occur during winter for the Southern Hemisphere, or summer for the Southern Hemisphere, winter for the Northern Hemisphere. And so the Southern Hemisphere Muslims will have really long days and really short nights. So it makes it a more strenuous fast, and then it will cycle out.
Right.
For those in the mid-latitudes, some of this variation isn't so bad, but for the communities in New Zealand and Iceland, this can be, during their summer, 20 hours or more of fasting.
Oof.
But they're working at ways of adapting, and it's a lively source of debate as to the appropriate way to observe these fasts within those communities.
Are Islamic calendar months as long as they're as long as the lunar cycle, so they begin and end at the full moon?
At the
Or the new moon?
waxing crescent.
Waxing crescent. Oh, you
So
mentioned that.
once you have a reliable sighting of the waxing crescent without using eyes alone, no binoculars, no help, then that begins the new month. If you've got a cloudy first, where you think the first of the month will be, then you count 30 days.
Okay.
So you wouldn't go 31 waiting to see getting a clear night. But if you have a crescent observed on the 29th day, then that's a month with 29 days. The Quran says, they ask you about the waxing and waning phases of the crescent moons. Say that they are fixed times for mankind in the Hajj. So the calendar is very, very much tied to the lunar cycle, and just doesn't matter so much what the weather is, what the seasons are.
Right. Okay.
So we have kind of started with the moon and its role in the calendar, in particular the supermoon that we're viewing, or any moon about this time of year, and its relationship to the major festivals and the calendars that define those. So encourage you to take a peek outside and see if it is as spectacular as we've hyped supermoon to be. But even if you can't distinguish it, I think any full moon is beautiful.
Absolutely. Absolutely.
Well, thanks for joining us here. And thank you to our astronomers for giving us such an informative presentation. We hope that you learned something, and we hope that you will take the next opportunity you have with a clear sky to go out and observe the moon. Happy watching.